So yeah, okay, so let me ask this question. Let's say I take a circuit like this. So I have shown the input and the output. Now let's try to find the number of poles and zeros here. Again, remember, the number of poles is the maximum number of capacitor voltages you can initialize in the circuit. For the pole location, the input doesn't matter, so I can assume that Vin is 0. Okay. So how many capacitor voltages I can define independently here? I can define voltage across this fellow and this fellow, no issues. So number of poles is how much? 2 poles. Similarly, let's quickly check the number of zeros. For the 0, I need to know the input output. So this is the input and this is the output. So how will I check how many zeros I have? What will I do? Yeah, let us say I can, if we can short any of the capacitors. If I short C2, what happens to the output? So this doesn't contribute to 0. What about C1? If I short C1, is the output 0? So how many zeros I can have? Can I have 2 zeros? Because if I short both of them at the same time, the output is 0. So how many zeros I have? How many zeros? 1 0. Why 2 zeros? I mean, if you need to have 2 zeros, I should be able to short 2 capacitors simultaneously and the output should still be non-zero. But here if I short 2 of them simultaneously, the output is 0. Yeah. So we have 1 0. Clear? Okay. But remember, the same circuit I can sort of redraw like this. That is, see, here I see that I have 2 poles. I know pole location doesn't matter, depend on the input and the output, correct? So which means I'll draw the circuit like this. Right? Now we can simplify the circuit like this, right? A single capacitor C equivalent. So how many poles this should have? 1 pole. But here I see that I have 2 poles, and in the particular example there was 1 0. So what's happening to the other pole in 0? I mean, sorry? Yeah, I mean, see, I see that if I look at this circuit, I have 2 poles, and for the input output combination I had 1 0, correct? Whereas I can simplify the circuit like this. I just seem to have only 1 pole. So I have an additional pole and an additional 0 that is not accounted for. So what do you think is happening to these two? They should exactly lie on the same location so that it cancels. And that's what actually happens. In fact, if you actually go and compute the transfer function using state variable analysis, you will end up with a case like this. You will have some 1 plus s times r times c times some s times something by s times something. So you'll have a pole and a 0 at s equal to 0, exactly cancelling each other. So if you have taken control systems, what is this called as? Huh? I mean, okay, this is called the transfer function. Yes, if you have a pole 0 cancellation happening, those state variables are called what states? Yeah. So if you have taken it, these are called as uncontrollable or unobservable states. Have you heard this term before? So what that means is, in general, if you have an uncontrollable or unobservable state, you will end up with a pole 0 cancellation. Because although I can define the 2 capacitor voltages independently, for the combination of input output I gave, you will end up with a case where only one state is controllable or observable, because the other kind of get cancelled. Again, this is just a side note to have in mind, not very critical when you design circuits. Okay. Okay, any questions so far? Okay, so let's move on. Let's look at the poles and zeros in our circuits.